Good afternoon, everybody. Today I am going to teach LAQs of binomial theorem. In binomial theorem, there are two LAQs. One is definite question of infinite series. 2 7 marks questions you will be getting. Today we will discuss all infinite series questions. Before going to this question, I will tell you two formulas. Based on these two formulas, the entire infinite series questions will follow. The first one, 1 plus x whole to the power minus p by q. 1 plus x whole to the power minus p by q. The expansion goes like this. 1 minus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square. For this question, we need only first 3 terms. So on. This is alternate series. Second one. 1 minus x whole to the power minus p by q. Power minus, inside also minus. 2 minus series are there. So it is positive series. 1 plus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square plus so on. By using these two formulas, I am going to discuss infinite series question, which comes for 7 marks. Question number 1. X is equals to, in the question it is small x. In formula we have to take capital X. X is equals to 1 by 5 plus 1 into 3 by 5 into 10 plus 1 into 3 into 5 by 5 into 10 into 15 plus so on up to infinity. Then find the value of 3x square plus 6x. Then find the value of 3x square plus 6x. So on infinity. So definitely it is infinite series question. The procedure goes like this. Given x is equals to 1 by 5 plus 1 into 3 by 5 into 10 plus 1 into 3 into 5 by 5 into 10 into 15 plus so on infinity. Before going to start this question, first you have to check whether the given series is complete series or not. Always the series must start with 1. Check here, it is starting with 1 by 5. How to check? There are 3 steps to follow. First, number of terms in numerator and number of terms in denominator must be equal. One term if you reduce, by the time you come at the end, it will be number of terms in numerator is 1, number of terms in denominator is 1. Then after that, number 1 will be there. So here, 1 by 1 term is there. So what is not there? Number 1 is not there. So adding 1 on both the sides. Adding 1 on both sides. If you add, this becomes 1 plus x is equals to 1 plus 1 by 5 plus 1 into 3 by 5 into 10 plus 1 into 3 into 5 by 5 into 10 into 15 plus so on up to infinity. One more thing we have to remember, in infinite series, the denominator must be in factorial. If not, we have to convert into factorial. Here factorial is not there. 1 plus, number is 5, right? 5 into 1. The remaining terms also write in terms of the products of 5. 5 is 5 into 1 and 10 is 5 into 2 plus 1 into 3 into 5 by, again 5 is 5 into 1, 10 is 5 into 2 and 15 is 5 into 3 plus so on up to infinity. 1 by 1 plus 1 by, write 1 as 1 factorial and take this 1 by 5 outside. Next, plus 1 into 3 by, inside 1 into 2 is there, 1 into 2 is 2 factorial. And how many 5s? 2 5s are there, take them to the other side. After the term, it is 1 by 5 whole square. Next term, it is 1 into 3 into 5 by, 1 into 2 into 3 is 3 factorial. And 1 by 5 whole cube it becomes. Plus so on up to infinity. Now it is perfect form. This step we have to compare the formula. Comparing with. It is positive series. All are plus signs only. So comparing with the second formula which I give, 1 minus x whole to the power minus p by q. This can be written as 1 plus p by 1 factorial plus p into p plus q by 2 factorial plus so on. First, on comparing LHS. LHS of the question is 1 plus x and LHS of the formula is 1 minus x whole to the power minus p by q. Take it as equation 1. Both are x terms only. In the question it is small x. In formula we are using it as capital X. Now compare RHS. In RHS, both first term is 1 only. Next term, in the place of p, 1 is given. So p is equals to 1. In the place of x by q, p by 1 factorial into x by q, p into p plus q by 2 factorial, x by q whole square, plus so on. This is the formula. Now, in second term, in the place of p, we have 1. Next, in the place of x by q, here we have 1 by q. X by q is equals to 1 by 5. Next, move to the third term. P value again 1. Already we have written. P plus q value is 3. P plus q is equals to 3. Substitute p. P is 1. 1 plus q is equals to 3. Q is equals to, if 1 goes the other side, minus 1. So q is equals to 2. Substitute q is equals to 2 in x by q. So x by 2 is equals to 1 by 5. So capital X value we got it as 2 by 5. Go to equation 1 and substitute. 1 implies 1 plus x is equals to 1 minus capital X value 2 by 5 whole to the power minus p by q. P is 1, q is 2. So 1 plus x is equals to 1 minus 2 by 5 is 3 by 5 whole to the power minus 1 by 2. So 1 plus x is equals to remove this negative power, write reciprocal of 3 by 5. It is 5 by 3. 5 by 3 to the power 1 by 2. To remove 1 by 2, what we have to do? We got 1 plus x is equals to 5 by 3 whole to the power 1 by 2. To remove this 1 by 2, squaring on both sides. Squaring on both sides. Left side 1 plus x whole square is equals to right side 5 by 3. Expand a plus b whole square. 1 plus x square plus 2x is equals to 5 by 3. Cross multiply with 3. 3 into 1 plus x square plus 2x is equals to 5. So 3 plus 3x square plus 6x is equals to 5. So 3x square plus 6x is equals to 5 minus 3. Therefore, he is asking 3x square plus 6x value. We got it as 2. So like how we have to do infinite series question. So before solving the question, first we have to check whether the given question is in complete form or not. Complete form means infinite series must start with 1 and denominator compulsory it is in factorial. These two steps by keeping, we have to follow the steps. Here it is starting with 1 by 5. So 1 is not there. First add 1 on both sides. Then every term in denominator is multiple of 5. By taking 5 as the factor, 5 into 1, 5 into 2, 5 into 3, write 5 as the multiple. Then separate the factorial term and the constant term. Compare with 1 minus x to the power minus p by q format. Both the sides LHS comparing and RHS comparing. Finally, we will be getting P, Q and capital X value. Take these three and substitute in equation 1. So we will be getting 1 plus x is equals to 5 by 3 whole power 1 by 2. Now after doing squaring on both the sides, we can get the value of 3x square plus 6x as 2. There are many questions in it. So different patterns are there. The concept is same. Only the adding term is different. So let me do few more questions so that you can understand easily. Next question. Question number 2. X is equals to 1 into 3 by 3 into 6 plus 1 into 3 into 5 by 3 into 6 into 9 plus 1 into 3 into 5 into 7 by 3 into 6 into 9 into 12 plus so on up to infinity. Prove that 9x square plus 24x is equals to 11. Prove that 9x square plus 24x is equals to 11. Same type of question. As I said, if infinity is there, blindly go for infinite series question. Solution goes like this. X is equals to, here also small x is given. 1 into 3 by 3 into 6 plus 1 into 3 into 5 by 3 into 6 into 9 plus 1 into 3 into 5 into 7 by 3 into 6 into 9 into 12 plus so on infinity. First check number of terms. How many terms we have to add here? If you observe, the last term, numerator 4 terms are there, denominator also 4 terms are there. When you go to the before term, number of terms 3, number of terms 3. Next, number of terms 2, number of terms 2. Up before what should be there? Number of terms 1 by 1. Then after that 1 should be there. So what is the adding term here? Adding both the sides by, first term is 1. Next term, how to identify? Close the last term here. So what left? 1 by 3. So adding both the sides by 1 plus 1 by 3. Now go to the question and add 1 plus 1 by 3 plus x is equals to 1 plus 1 by 3 plus 1 into 3 by 3 into 6 plus 1 into 3 into 5 by 3 into 6 into 9. Last term you can ignore. So on infinity. Now 1 plus 1 by 3 is 4 by 3 plus x as it is equals to, if you observe denominator, all terms are multiples of 3. So write products of 3. 3 can be written as 3 into 1. 1 into 3 by, here again 3 is 3 into 1. 6 is 3 into 2 plus 1 into 3 into 5 by 3 is 3 into 1, 6 is 3 into 2 and 9 is 3 into 3 plus so on up to infinity. Now 4 by 3 plus x is equals to 1 plus 1 by, take only 1. 1 can be written as 1 factorial. And this 1 by 3 right outside of the term. Plus 1 into 3 by inside terms 1 into 2. 1 into 2 is 2 factorial. And how many 3's are there? 2 3's are there right outside 1 by 3 whole square. Plus 1 into 3 into 5 by 1 into 2 into 3 is 3 factorial and here 1 by 3 whole cube plus so on. Now it is the perfect format of the formula. Now we have to compare. Comparing with positive series. So infinite series, positive series formula 1 minus x whole power minus p by q is equals to 1 plus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square plus so on. Now first take LHS and compare. LHS implies, LHS of the question is 4 by 3 plus x and LHS of the formula is 1 minus x to the power minus p by q. Take it as equation 1. Similarly, take RHS and compare. In RHS, both first term is 1. In second term, p value is 1. And in the place of x by q, it is 1 by 3. Go to the third term, p is 1 already written. P plus q is 3. Now substitute p value. 1 plus q is equals to 3. So q is equals to 2. Now go to the question. Go to equation 1. 1 implies 4 by 3 plus x is equals to 1 minus capital X value. What is capital X value? X by q. X by q is 2. 1 by 3 cross multiply. So capital X value we got it as 2 by 3. Substitute here 1 minus 2 by 3 to the power minus p by q minus 1 by 2. So 4 by 3 plus x is equals to 1 minus 2 by 3. 3 is LCM. 3 minus 2 is 1 to the power minus 1 by 2. Now 4 by 3 plus x is equals to remove this negative power, write reciprocal of 1 by 3 is 3. 3 power 1 by 2. Only removing minus, I am taking the reciprocal of inside bracket. Power 1 by 2 as it is. Now 4 by 3 plus x is equals to 3 power 1 by 2. Here take LCM. 3 is LCM. 4 plus 3x is equals to 3 power 1 by 2. So do squaring on both sides. 4 plus 3x by 3 whole square is equals to 3. 3 power 1 by 2 whole square. 2 and 2 getting cancelled. Numerator a plus b whole square. A square, that is 4 square, 16. B square, 3x whole square is 9x square. plus 2ab, 2 into 4 into 3x, 24x divided by 3 square is 9 is equals to 3 left out. Cross multiply. So 16 plus 9x square plus 24x is equals to 9 3 is the 27. We want 9x square plus 24x value. 9x square plus 24x is equals to 27. Take this minus plus 16 to the right side. So it becomes minus 16. So 9x square plus 24x is equals to 27 minus 16 is 11. Like this, we have to solve the question. So like this, we have to solve infinite series question. So first question, we added 1 on both sides. There was only one term missing. In second question, 2 terms were missing. So we added 2 terms. So we'll see the next third one. Third one. If t is equals to, small t is given. If t is equals to 4 by 5 plus 4 into 6 by 5 into 10 plus 4 into 6 into 8 by 5 into 10 into 15 plus so on. Then prove that 9t is equals to 16. Then prove that 9t is equals to 16. This is also same type of format. So to compare infinite series, which term we have to add? How many terms are missing that we have to check? Solution. So first take the given series. T is equals to 4 by 5 plus 4 into 6 by 5 into 10 plus 4 into 6 into 8 by 5 into 10 into 15 plus so on is given. So if you observe, first term is single term by single term. So all terms are there except one. So adding 1 on both sides. Adding 1 on both sides. So by adding 1, it becomes 1 plus t is equals to 1 plus 4 by 5 plus 4 into 6 by 5 into 10 plus 4 into 6 into 8 by 5 into 10 into 15 plus so on. Now the rest of the procedure is same like previous question. 1 plus t is equals to 1 plus 4 by denominator 5, write it as 5 into 1 plus 4 into 6 by 5 into 1 and 10 is 5 into 2 plus 4 into 6 into 8 by, here again 5 into 1, 5 into 2, 5 into 3 plus so on. is equals to 1 plus 4. 1 write it as 1 factorial and outside 1 by 5 plus 4 into 6 by 1 into 2 is 2 factorial 1 by 5 whole square plus 4 into 6 into 8. 1 into 2 into 3 is 3 factorial 1 by 5 whole cube plus so on. One plus t. So it is perfect form. We have to comparing with infinite series positive term formula. 1 minus x whole power minus p by q is equals to 1 plus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square plus so on. With this we have to compare. Compare LHS of both. We are comparing LHS of both. Here what is their LHS? 1 plus t. And in the formula LHS is what? 1 minus x to the power minus p by q. Take this is equation 1. Next, RHS compare. When you compare RHS, both first term is 1. In the place of p, we have 4. And in the place of x by q, we have 1 by 5. When you go to the next term, in the place of p plus q, we have 6. Substitute p value. 4 plus q is equals to 6. So q is equal to 6 minus 4, it is 2. So x by q, q means 2 is equals to 1 by 5. So x is equals to 2 by 5. Go to equation 1 and substitute. 1 implies, what is equation 1? 1 plus t is equals to 1 minus 2 by 5 to the power minus p by q. P value is 4 and q value is 2. So 1 plus t is equals to LCM 5. 5 minus 2 is 3 to the power 2 1 the 2 2 the. So here what we have to write? 2 1 the 2 2 the whole square will left out. So 1 plus t is equals to 3 square is 9 by 5 square is 25. Cross multiply. It is to the power minus 2 it is. To remove power negative, write reciprocal. 5 by 3 whole square. So left out what? One plus t is equals to 25 by 9. Because 5 square is 25, 3 square is 9. Cross multiply. 9 plus 9t is equals to 25. Therefore, 9t is equals to, if 9 goes the other side, 25 minus 9 is 16. 25 minus 9 is 16. So this is how the proof goes. Copy down the question. If you have a doubt, just you can drop your message. move to the next question. The similar type, we have one more question. Find the sum of the series, find the sum of the infinite series infinite series 3 by 4 into 8, 3 by 4 into 8 minus 3 into 5 by 4 into 8 into 12 plus 3 into 5 into 7 by 4 into 8 into 12 into 16 minus so on to infinity. Here only sum he is asking. So when question is about sum, let S is equals to, take the given series 3 by 4 into 8 minus 3 into 5 by 4 into 8 into 12 plus 3 into 5 into 7 by 4 into 8 into 12 into 16 minus so on. Yeah, first step what we have to check, it is not a complete series. There are some terms are missing. First step, number of terms in numerator and denominator must be same. If you observe, number of terms in numerator is lesser than the denominator. We'll see which term we have to add to the series. The series is odd series in the numerator. The last term, if you take 7, 7 before term is 5, 5 before term is 3. 3 before odd number is what? 1. So directly you can write multiple of 1 into 3 by 4 into 8. Because if we multiply or divide with 1, there is nothing to change. So directly you can write like this. 4 into 8 into 12 plus 1 into 3 into 5 into 7 by 4 into 8 into 12 into 16 minus so on. So we made number of terms equal in numerator and denominator. Next we have to check which terms are going to add. Here first term starting with number of terms are 2 terms by 2 terms. Next before what should be there? 1 term by 1 term. Next number 1 should be there. It is alternate series, plus minus is there. So adding both the sides by first 1 compulsory, alternate series means minus. What is the next term? If you close 3 by 8, it is 1 by 4. So adding both the sides by 1 minus 1 by 4. Add to the LHS 1 minus 1 by 4 plus S is equals to 1 minus 1 by 4 plus 1 into 3 by 4 into 8 minus 1 into 3 into 5 by 4 into 8 into 12. We can ignore the last term plus so on infinity. Same like previous question. 1 minus 1 by 4, 4 LCM. 4 minus 1 is 3. 3 by 4 plus S is equals to right side 1 by every term is multiple of 4 in the denominator, right? Product of 4. 4 is 4 into 1. In the same way, second term 4 is 4 into 1 and 8 is 4 into 2 minus 1 into 3 into 5 by 4 is 4 into 1, 8 is 4 into 2 and 12 is 4 into 3 plus so on up to infinity. Now 3 by 4 plus S is equals to 1 minus 1 by 1, write it as 1 factorial and writing 1 by 4 outside. plus second term 1 into 3 by 1 into 2 is 2 factorial and there are two 4s. If it write 1 by 4 whole square minus 1 into 3 into 5 by 1 into 2 into 3 is 3 factorial and there are 3 4s 1 by 4 whole cube plus so on. Now it is alternate series. So alternate series comparison, comparing with formula 1 plus x to the power minus p by q. Alternate series in between plus will be there is equals to 1 minus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square, so on. First compare LHS of both. What is LHS of the question? 3 by 4 plus s. So 3 by 4 plus s is equals to, in the formula LHS, 1 plus x whole to the power minus p by q. Take this is equation 1. Now compare RHS. Both are having first term 1 and second term minus 1 is there and in the formula minus p is there. So directly you can take p is equals to 1. And x by q value we have 1 by 4. Next, third term p plus q. P plus q. What is the second term in third? 3. So p plus q value is 3. Substitute p. 1 plus q is equals to 3. Q is equals to 3 minus 1, that is 2. So x by q means 2 is equals to 1 by 4. 2 1s are 2 2s are. So capital X value we got it as 1 by 2. Go to equation 1 and substitute. 3 by 4 plus s is equals to 1 plus x is 1 by 2 to the power minus p by q, that is minus 1 by 2. So 3 by 4 plus s is equals to LCM 2, 2 plus 1 3 to the power minus 1 by 2. So 3 by 4 plus s is equals to remove the negative power, write reciprocal. 2 by 3 whole to the power 1 by 2. He is asking the sum. So only s value we want. S is equals to 2 by 3 to the power 1 by 2 and take 3 by 4 to the right side. It becomes minus 3 by 4. One last step. 2 by 3 power 1 by 2 we can write it as square root of 2 by 3 minus 3 by 4. So like how we can conclude. Just go through the question once again. In infinite series, first thing we have to make number of terms in numerator and denominator are equal. So here if you observe numerator there are 3 terms, denominator there are 4 terms. And here numerator 2 terms, denominator 3. And here numerator 1 term, denominator 2 terms are there. So to simplify, first make the number of terms equal. So for that what I did? Multiplied with 1 in the numerator. So all terms became equal. Then added the shortage term, that is 1 minus 1 by 4 both the sides. Simplified. Compared to infinite series formula. Taken the values of LHS and RHS. Substituted P, Q and capital X value in equation 1. So we got the sum S is under root 2 by 3 minus 3 by 4. One last question of infinite series. There is one more question. Find the sum of the series. Find the sum of the series. Seven by 5 into 1 plus 1 by 10 square plus 1 into 3 by 1 into 2, 1 by 10 power 4 plus 1 into 3 into 5 by 1 into 2 into 3, 1 by 10 power 6 plus so on. Question, find sum is given. When sum is given, the given equation or given series, take it as S. S is equals to 7 by 5 into 1 plus 1 by 10 square plus 1 into 3 by 1 into 2, 1 by 10 power 4 plus 1 into 3 into 5 by 1 into 2 into 3, 1 by 10 power 6 plus so on. If you observe, the series is starting with 1. So some minor changes we have to make here. First, send 7 by 5 multiple to the left side. It becomes reciprocal. The reciprocal of 7 by 5 is 5 by 7, S as it is. Five by 7, S is equals to. First term is 1 plus second term, what we need? 1 by 1 factorial we need, right? It is not there. So we can take 1 factorial and inside the bracket, whatever the term is there, right? That is 10 square. Next term, 1 into 3 by 1 into 2 directly we can write it as 2 factorial. And 1 by 10 power 4, shall I write? 1 by 10 square is first term. Multiple of it. Because 2 to the 4. Next, 1 into 3 into 5 by 1 into 2 into 3 is 3 factorial. This can be written as 1 by 10 square whole cube plus so on. Now it is the perfect form of infinite series. So comparing with series is positive series. So 1 minus x whole power minus p by q is equals to 1 plus p by 1 factorial into x by q plus p into p plus q by 2 factorial x by q whole square plus so on. First compare LHS. 5 by 7 S is equals to 1 minus x to the power minus p by q. Take it as equation 1. Next compare RHS. In the place of P1, in the place of x by q, 1 by 10 square. In the place of p plus q, it is 3. Substitute p value. Substitute p value. 1 plus q is equals to 3. So q is equals to 2. Then x by q, x by 2 is equals to 1 by 10 square. 10 square means 100. 2 ones are 250s are. So capital X value we got it as 1 by 50. Go to equation 1 and substitute. Equation 1 is 5 by 7 S is equals to 1 minus capital X. What is capital X? 1 by 50 to the power minus p by q. P value is 1 and q value is 2. So 5 by 7 S is equals to, take LCM 50. 50 minus 1 is 49 to the power minus 1 by 2. To remove the negative power, make the reciprocal. 49 by 50 reciprocal is 50 by 49 to the power 1 by 2. Now, 5 by 7, S is equals to 50 by 49 to the power 1 by 2 can be written as square root of 50 by 49. Square root of 50 by 49. Now, 5 by 7, S is equals to square root of 50, right? 25 into 2. By square root of 49 is directly we can write 7. 5 by 7, S is equals to square root of 25 is 5 and square root of 2 as it is by 7. Both the sides 5 cancel and 7 cancel. Therefore, the sum of the given series is what? Root 2. So like how we have to complete the infinite series question. Most important question, just practice these questions. Whatever the doubt you have, you can ask them. So with this, I am concluding today's session. Thank you.